Now let's prove the next statement. I will leave this for you as an exercise. This actually should be quite similar to the theorem 4.1.1, a good exercise for you. Let's take a look at the next one. Prove that the square of an odd integer is odd. So again, my first step will be trying to rewrite this into a conditional statement, right? So now, square of something is odd. That will be my conclusion. And what is my assumption? This odd integer is my assumption. So therefore, I'm going to rewrite this. If x is an odd integer, then square of it, x squared, is odd. Okay, so this is my conditional statement. And if you want to write this into universal conditional statement, I simply can just say for all x in z, if x is odd, right? If x is odd, then x squared is odd. So that will be certainly doable, but I'm gonna just go with conditional statement. That should be enough. Now this is just a restatement of the problem that we want to prove. Okay, here's what we want to prove, right? And how do we begin our proof? You have to assume something to begin with. Okay, you're gonna assume that if this is your hypothesis, so you're gonna assume. Earlier I used suppose or assume. Now I'm gonna use let. Okay, just so that you get exposed or get used to both different words. So let x be an odd integer. Now the next one is want to show. Okay, what do we want to show? That's the conclusion we want to conclude. That means we want to show. We want to show x squared is odd. So in the future, when you're getting more and more proficient, sometimes this can be skipped. But I would not think this is a good idea at this moment. I would like you to continue to write it out. And actually, what I would suggest will be, i.e., just do a little more interpretation. What does it take for x squared to be odd? In other words, x squared is equal to 2 times some integer plus 1 for some integer, right? Some integer, that's for some integer k. So that's basically that's the goal. Once you get to this point, you can make this conclusion automatically. It's true. All right, let's begin with let x be an odd integer. Since x is odd, right? Therefore, according to the definition, x is equal to 2r plus 1 for some r. Again, we have an agreement that lowercase represents integers, so sometimes I can, in writing, I sometimes even skip this r in z, but I'm gonna completely okay to skip that. Basically, that's what I'm saying. So now, therefore, keep in mind what you're trying to find. You're trying to show that x squared is odd. So you want to somehow involve x squared. Therefore, I'm gonna do x squared, which is 2r plus 1 squared, right? And use expanded, which is 4r squared plus 4r plus 1. I'm using the identity like a plus b squared equals a squared plus 2ab plus b squared. That's the identity I'm using. A is my 2r, b is 1, so apply it. Okay. Now verify that for me. Now, again, always keep that in mind. That's your goal. You want to show that x squared, which is this guy, you want to show that it can be written into this form. And I do see already there's a plus 1 over there, so I try to rewrite this part into 2 times some integer. So therefore, I'm going to continue to work on that. So again, I group these two together. I actually want to factor out a 2 so that I have 2r, 2r squared actually, plus 2r plus 1, right? Do you see that this is actually an integer? That's what's going to be your k. So therefore, x squared is odd. Okay, some may ask, isn't that you have to call it a k? You can, but you really not really necessary. This is already showing 2 times some integer. I know r is an integer, therefore r squared is an integer. 2 times r is integer, plus another integer has to be integer. But certainly it's completely okay to rewrite it as 2k plus 1, where you're going to assign k to be 2r squared plus 2r, right? So now you can conclude x squared is odd, because that's exactly what to be proved, right? Which is to be proved. Okay, then you end the proof. All right, so let's quickly take a look at the next one. Right at the beginning of your proof, only include the starting points and what to be shown. You don't have to finish your proof, but you're welcome to finish the proof. Here, the product of 2 odd number is odd. Okay, so because we have 2 odd numbers, we need 2 variables. Let's first rewrite that into universal conditional statements. Again, odd numbers. So I would say we are talking about integers. Otherwise, it doesn't make sense to talk about odd or even. So I would say for all, I need 2 variables, m and n, for arbitrary 2 integers, m and n, if they are odd, right? If m and n are odd, then here's the conclusion. The product is odd, then m times n is odd. So this is, I might just translates that into symbolic form. Now here's the starting points. So here's usually how you start the proof. What do you begin with? You are gonna assume, start with your hypothesis, and this is your hypothesis. So suppose or say let or assume, any one of those words will good. So I'm gonna assume, just to make sure you know, we use different words. They're all okay. So assume m and n are odd. Okay, and then the next is we want to show, right? Want to show m times n is odd. Okay, in other words, so oftentimes I really encourage you to translate, like, what does it take for this to be true? So in other words, m n is equal to 2 times some integer, say 2k plus 1 for some k. This is really a good reminder for you to, hey, what do you need to get to? This is what you need to get to. Okay. All right. So I feel like this question is actually a very good question for you to practice the proof. Strongly encourage you to continue. For section 4.2, really nothing much new. However, there are a lot of good information for you to take away from section 4.2. It has the instructions, like suggestions, how to start your proof, how to write the proof, the steps for proof. And it also provides many very commonly seen mistakes for beginners, for proof beginners. They oftentimes make. So it's very good to read through this section 4.2. I definitely want you to take that as a reading assignment. Read carefully for every sentence from section 4.2.